So here is the solutions stoichiometry problem. Lead to nitrate, reacting with potassium chloride to form lead 2 chloride and potassium nitrate. And so oftentimes when we're doing chemical reactions, especially when we have a double replacement reaction like this with two ionic compounds, we're going to dissolve those compounds in water so that the compounds can ionize, forming ions, so that floating around in the solution we would have lead ions, nitrate ions, potassium ions, and chloride ions, and that's how they can easily switch places. And so as we're taking a look at something like this, when we have a solutions stoichiometry problem, the first thing that I would suggest you do, or the first thing I like to do, is I just like to remind myself of the formulas. I like to remember that molarity equals the number of moles divided by my volume of solution in liters. And so molarity times my volume in liters equals my number of moles. And that's often one you're going to start with when you're doing problems like this. I also want to know that my number of moles divided by the molarity is equal to the volume in liters again. And so as I'm taking a look at this, I can see that I have my molarity, or my concentration of my lead to nitrate, and I've got my volume of my KCl, but of course that is in milliliters, so I'm going to need to move that decimal over 3 places to turn it into liters. And then I also have my concentration, or my molarity, of my KCl. So I have volume and molarity for KCl, so that's what I'm going to start with. And whenever you're given a chemical equation with some solution information, you're going to need to use solutions stoichiometry, not just M1V1 equals M2V2. And so as I start with this, I am going to take that my volume, 0.05. Now I'm not going to worry about my significant figures yet. And that's going to be liters of KCl. I'm going to come back at the end and worry about my significant figures, times my molarity. And I know that's going to give me my number of moles, because that's what my equation says. And the reason this works is because this big M is really moles divided by liters. So this allows the liters to cancel out, and you're left with moles. And that's going to be moles of KCl. Now I could stop there and find my answer, or I could keep going. And I'm going to keep on going, because what I want to do is take a look at my equation here. And I want to notice that 1 mole of lead 2 nitrate is equal to 2 moles of KCl. So I'm going to use that relationship there to convert from my moles of KCl to my moles of lead 2 nitrate. Notice that as I'm filling this in, my moles of KCl will cancel out. And when I work out the math, 0.05 times 1.5 times 1 divided by 2, that is going to equal 0.0375. And that's going to be moles of lead 2 nitrate. And I am looking for the volume of lead 2 nitrate in milliliters. And so if I take my my number of moles here and use this equation right here, my number of moles divided by my molarity, that's going to give me my volume. Now, of course, that's going to be volume in liters, so I'll have to convert it back to milliliters. So I'm simply going to divide that by what's given in the problem, which is 2 molar lead nitrate. Whoops. Let's make that say PB. And that's going to give me, when I work out that math, I'm going to put that right over here. 0.01875 liters, which I wouldn't really even be able to get in the lab because any cylinder that holds a liter is not going to show me 0.01. Oh, and sorry, that's liters. I'm thinking I need to convert that to milliliters, which I do. And so once again, all I'm going to do is move this decimal over 3 places. So we got 18.75 milliliters. I'm going to take now a look at my problem, and I see that in each of my measurements there are 3 significant figures. So I'm going to round this to 3 significant figures to get 18.8 milliliters of lead 2 nitrate. And there is my final answer. So it is kind of a lot to go through to calculate these, but that's exactly what you would want to do. Take 18.8 milliliters of that lead 2 molar lead 2 nitrate, put that in your reaction vessel with 50 milliliters of your 1.5 molar KCl. Now I do have another one for you to practice. It's a slightly different one to practice on your own. Once again, when you're given an equation and you're given information about solutions, you want to use your solutions stoichiometry, not just M1V1. So take a look at this problem and see what you can do. So now that you've finished that problem, I've gone ahead and worked this out as well, the same way I'd done the previous one, except for this one was asking for the concentration of the H3PO4, the phosphoric acid. So take a look. There's my final answer, rounded to 3 significant figures, since that's the measurements given in my problem, and check to make sure that you got that correct.